Hi all, let's continue with the main memory. So in today's lecture, we are going to see how the main memory is connected to the CPU, memory connection to the CPU and memory address map. Coming to the memory connection to the CPU, the main memory which consists of a RAM and a ROM chips, they are connected to a CPU by means of data and address buses. So let us see a main memory which is composed of RAM and ROM and which is connected to a CPU. If you see this particular diagram, this is your main memory which is designed using 4 RAM chips and 1 ROM chip, where each RAM is of capacity 128 bytes of 8 bits each. So since our chip selection inputs are 2, we have 2 to the power of 2, 4 RAMs present in our CPU and 1 ROM, and the ROM capacity is of 512 bytes of 8 bits each. So this is nothing but your main memory. And we also have a CPU which consists of a data bus and address bus. Data bus is used to perform and read and write operation from the main memory to the CPU and from the CPU to the main memory. So in case of a RAM, it is a bidirectional data bus is used where you can perform a read and a write operations between the main memory and the CPU. But in case of ROM, it is a unidirectional data bus because you can perform only a read operation on the ROM chip. So we have the data bus connected only towards your from the ROM towards your CPU. Next, coming to the CPU, we have an address bus. So, address bus contains addresses starting from 1 to 16 addresses. But with regards to the connection to the main memory, we are using only the addresses from 1 to 10. 11 to 16 are not used here. And we also have a read and a write inputs. So, let us see how these particular connections are made between the CPU and the main memory. First, coming to a write input. So here if you consider the RAMs, all the RAMs they contain two chip selection inputs CS1 and CS2 bar, read input, write input and address bus. Since it is a 128 byte RAM 2 to the power of 7, so there are 7 address bits AD7 represented by AD7. Similar for all the 4 RAMs. Consider the ROM. So in case of ROM, as we know, there is no write operation. The only thing that you can perform on a ROM chip is a read operation. So we are not having any specific read or write inputs in case of a ROM chip. And the address bit is of a 9-bit address because it is of size 512 bytes into 8 bits. So 512 means 2 to the power of 9. So you have 9 address bits represented by AD9, and you have only the chip selection input CS1 and CS2 bar, and both the RAMs and the ROM are they are connected to a CPU through the data bus. So this is a data bus. In case of a RAM, it is a bidirectional data bus. In case of a ROM, it is a unidirectional data bus. So the connections are made such that if you look at the right input is connected to all the right inputs of RAM. So you are going through this right input. This right input is connected to all the right inputs of the RAM chips. Since we are not connecting the right input to a ROM because you are not going to perform write operation on a ROM. You are supposed to perform only a read operation. So when it comes to a read input, it is connected to all the read inputs of your RAM, as well as it is also connected to CS1 of your ROM. So since we don't have a read input in a ROM chip, we are connecting it to CS1. Next, coming to a address bus where we have 1 to 10 addresses. As we know, all the RAM chips are specified by 7 addresses represented by AD7. So address bits specify the particular address of a RAM. So 1 to 7 represents the address which is connected to AD7 of all the RAM chips. So it is connected to 87 of all the 4 RAM chips. Similarly, the address of your ROM also contain a 9-bit address out of 7. 1 to 7 bits of your address are connected to this particular ROM chip also. So 1 to 7 of this particular address is connected to a ROM chip. Next comes to a 8 and 9 bits. So 8 and 9 bits specify which RAM is particularly selected to perform a read operation or a write operation. Say I want to perform a write operation on this particular RAM too. So how can that particular CPU select the particular RAM is based on 8 and 9 bits. So these 8 and 9 bits are given to an input to a decoder, 2 by 4 decoder, which takes a 2-bit input and 4-bit output. So each of the output of your decoder specifies one particular RAM. So if it is 0, if the output is 0, which means the first RAM. If the output is 1, it means it is the second RAM. If the output is 2, it means it is the RAM 3. If output is 3, it is RAM 4. So if the output of your decoder is 00, it means the first RAM is selected. If it is 01, the second RAM. 10, the third RAM. If the output is 11, the fourth RAM. So this particular decoder takes 2-bit input, the 8 and 9 bits of your address bus, and it gives a four outputs. That outputs determine which RAM will be selected to perform a read or a write operation. And these 8 and 9 bits, they also acts as an address bits for your ROM if particular ROM has to be selected. So 8 and 9 bits also specify the address bits of your ROM. Now, in order to select a RAM, you are going to select it based on the decoder output, depending upon the decoder output. Say, for example, when you have to select ROM to perform a read operation on the RAM, the CPU. In that case, that is done by means of bit 10. So, bit 10 specifies whether you want to select a RAM or a ROM. If your 10th bit is a 0, then RAM has to be selected. If the 10th bit is 1, then ROM has to be selected. So this 10th bit is given as an input to CS2 bar. So CS2 bar is given as an input, the 10th bit. So if the 10th bit is 0, the entire RAM is selected. Again, which RAM of this particular 4 RAMs depends upon your 8 and 9 bits. So if it is a ROM directly, if your 10th bit is 1, it indicates the ROM has to be selected to perform a read operation. So since we are complementing, if it is a 0, it means RAM. So if it is a 1, since we are giving a complement, it means when it is a 1, ROM will be selected. So this is how the connection is made between the main memory and the CPU through an address and data bus of the CPU that has to be connected to your RAM chips as well as the ROM chips in order to perform a read or a write operation between the main memory and the CPU. So each RAM receives the 7 low order bits of the address bus to select one of the 128 possible bytes of your RAM. So and this is done through a 2 by 4 decoder whose outputs goes to the CS1 inputs in each RAM. So the particular RAM chip is selected. Which RAM chip is selected determines from the lines 8 and 9 in your address bus. So when your address lines 8 and 9 are equal to 00, the particular RAM 1 will be selected. If it is 01, RAM 2 is selected and so on. And read and write outputs from the microprocessor are applied as an inputs to your RAM chip, read and write inputs. And the selection between a RAM or a ROM is achieved by means of a 10th bit. The 10th bit is a 0, it means the RAM is selected. If it is a 1, it means ROM is selected. So address bus lines 1 to 9 are applied as an inputs to your ROM. Whereas address lines from 1 to 7 are applied to your ROM as well as your RAMs. Next one is the memory address map of your main memory. So memory address map is nothing but it is a pictorial representation of an assigned address space for each and every chip in the system. So you have a ROM chip as well as a RAM chips. So memory address map will tell you about a pictorial representation of what is the address space that is allocated to that particular chips that are present in your system. So assume the same example we are considering where we are assuming a computer system which contains a 512 bytes of RAM and 512 bytes of ROM. Okay. Now let us look at the memory address map table. So this is the memory address map of your RAM and ROM chips present in your computer. So as per the diagram, we have 4 RAM chips and 1 ROM chip. So this memory address map table mainly contains 3 columns. The first column is your component column. The second column specifies the hexadecimal address assigned for each and every chip. And the third column specifies the address bus. Okay. So the component column specifies whether it is a RAM or a ROM. Okay. That is your component column. The next is the hexadecimal address. The hexadecimal address column specifies the range of address that is assigned to that particular chip. So if you consider the RAM one, the address space is between 00000 to 007F. So this is the range of address that is allocated to that particular RAM one. So that specifies the hexadecimal address column. And the third column is your address bus. So as we know, connections between the memory and CPU, the address bus contains a 16-bit address. But we are not using the bits from 11 to 16, we are using only from 1 to 10. So they are specified in the address bus column. So if you see this, there are 4 RAMs and 1 ROM. Whereas for a RAMs, the address specifies from 1 to 7. So 1 to 7 is nothing but your addresses for all the 4 RAMs. And for the RAM, it is a 512 bytes ROM. So it is a 9-bit address. So it specifies from 1 to 9. Okay. So and to which RAM has to be selected, whether it is a RAM 1, RAM 2, RAM 3, RAM 4, that depends upon your 8th and ninth bit. So if 8th and ninth bit are 00, RAM 1 will be selected. If it is 01, RAM 2, 10, RAM 3 and 11, RAM 4. That is how the address bus is specified for each and every RAM. Similarly, the 10th bit specifies whether it is a RAM or a ROM. So whenever your 10th bit is a 0, it means that the RAM is selected. And whenever your 10th bit is 1, it means that the ROM is selected. So this is how you are mapping each and every chip of your computer to the particular hexadecimal address and your address bus. So this is called memory address map. So the component column, it specifies whether a RAM is used or a ROM chip is used. Next column is the hexadecimal address. It assigns a range of hexadecimal equivalent address for each and every chip that is present in your computer. And the third column specifies your address bus lines. The RAM chip has 128 bytes and needs 7 address lines, and the ROM chip has 512 bytes, so it requires 9 address lines. And when the 10th line 10 is a 0, the CPU selects a RAM. When this is equal to 1, it selects a ROM. So this is called as a memory address map, which is a pictorial representation of assigned address space for each and every chip that is present in your computer system. So this is about main memory. Thank you.